Okay, let's begin with our DSA course with searching algorithms. So, to search means to find the existence of something in a collection. Okay, so there are different searching algorithms. Let me tell you, in most of the interviews or like in any test, they ask only these two, linear search and binary search. But you should know that many searching algorithms exist. I will just give you the overview of other searching algorithms. Sorry, plus we will code for linear search and binary search. So let's first look at linear search. Linear search is applied on unsorted data. What is unsorted? Unsorted means a random collection of data. This is random collection of data. I want to find 690 using linear search. In linear search, we simply apply a for loop, just move our pointer one step ahead and check the existence of element. If the element exists, we return its index, else we return -1. Like in this simulation, as you can see, we are moving one step ahead to find the element at every index. As we can see at the index 21, we found the element 690. So we return result 21. This is the Python code given here. Okay, so for now, you don't know about time and space complexity. If you don't know, then ignore. If you know, then it's fine. The time complexity of linear search is order of n. N means suppose we have like 500 elements. In the worst case, that element should exist at the last index 499. So in that case, we have to traverse all the array. So in because of that, it is order of n. Now let's code for linear search. I am gonna code in C. If you want, you can code in any language. I hope your basics are clear with C and C++ and you know these languages in detail. This is gonna be advanced course for DSA. Okay, so let's declare an array. Let it be of size 10 and let me enter the elements. Okay, these are 10 elements. Now let's create a separate function, linear search. It will receive an array and the size of collection int as well and the key which we have to find. So here I have created a separate function as linear search passing the array and size as 10 elements and for now let key be 56. And for linear search we will simply apply a for loop for int I equal to 0, I less than sz plus I. If array of I is equal to key, we will return I, else we will return -1, element not found. So let's compile the code and execute it. We have got the element at index 4. Let's try some different element, let it be 55. So 55 is not found, that's why we got -1. Now let's move towards another searching algorithm, which is binary search. In this, the necessary condition is that all the elements must be sorted. Either they are arranged in the ascending order or in the descending order. So for now we have element 257 which we have to search in this collection. So binary search works on strategy of divide and conquer. As we already know that this array is in ascending order, sorted in ascending order. We know that as we move ahead, we are going to get larger elements. So suppose let's we have to find 257. We know that 257 doesn't exist in this array. So it should return -1. For now, for our understanding, let's take 247 as it exists in the array. So in binary search, what happens? We take two variables, lower bound and upper bound. Lower bound should be set at the 0th index and upper bound should be set at the last index of the array. Then we calculate mid. Suppose 0 and 31, we get mid as 15th index. Now we check the data at 15 index, is it equal to our key, which is 247, then we return it. Else not, we will compare it. If the element at index 15 is greater than what we are looking for, then it is definitely sure that the right part is going to contain all the larger elements. So we are going to skip that right part. So it is obvious that the element will be existing in the left part. So we will eliminate the right part by setting upper bound as mid -1. You can see the now let's find another mid. With this new lower and upper bound, we found mid at index 7. Now we again compare with our element. Now the element at index is smaller. So we know that left part has all the smaller elements. So we can ignore the left part. And now look for the element in the right part. And similarly, we repeat this process continuously. And we found the element at index 9. Now let's code for it. I can copy the same. Okay, now we need to do some modification. No, it's not required. We already have the size. Now let's take two variable LB as lower bound and UB as upper bound. So lower bound will always be 0 and upper bound will always be size -1, the last index of the array. Now we will apply a loop, while loop until lower bound is less than or equal to upper bound. And we will also be requiring one variable that is mid. And when the loop ends, it means we do not found the element, we will return -1. So in the loop, we found mid as lower bound plus upper bound divided by 2. And if element at mid index is equal to our key, we are gonna return the mid index as our answer. And if element at the index, the mid index is greater than the key, this line shows that if like we found the mid and the element at the mid is greater than the key, means the key is to exist on the left hand side, or we can ignore the right hand side. So we set upper bound as mid -1, else we can set lower bound as mid +1. Now let's compile this code. Okay, the element is not found. We were searching for 55. Now let's search for 56. It's found at index 4. So what's the difference between linear search and binary search? Suppose there are 1 crore elements in an array. So if the element exists as the last index, the linear search will definitely gonna take 1 lakh iteration. Like I said, 1 crore. It will gonna take 1 crore iterations. While the binary search can do the same within 25 iterations if the array is sorted. So this is the power of binary search. If we talk about complexity, so linear search complexity is order of n in worst case, and binary search it's order of log n. If you are not much comfortable with time and space complexity, for now rest assured I will teach you in the upcoming lectures. Now let's move towards another searching algorithms like jump search. What happens in jump search? Like here, yeah, it's given jump ahead by fixed block. We jump ahead by fixed block of size under root n. Like in our case, we were having size of array as 10. We were having 10 elements. Now let's take the under root. Its integer part is 3. So what happens in jump search? Let me copy linear search as jump search. Okay. It is somewhat similar to linear search. Let me change the name. Okay, array size, and the key we are finding is, let it be 79. Okay. So what happens in jump search? First, I am gonna take a variable I and jump. So jump is similar to under root of size. Now for that we can use square root function. For that we need to include math.h. I think square root returns double values, so we would be requiring to typecast it into integer. We will see that. Let's set I equal to 0, and while I is less than sz, we are gonna do I plus equal to jump every time. And if at any case our array of I index element is greater than the key, then we are gonna break. Now let's search for the element in reverse linear order. While I is greater than equal to 0, let's take another variable. It will be easy to remember. Let's take j. Okay, j is I, and while j is greater than equal to 0, and then j is greater than equal to I minus jump, we are going to do j minus minus. And if array of j is equal to key, we will return j, else we will return minus 1. And what if while doing I plus equal to jump we cross the sz mark? So we will check if j is greater than equal to sz, j should be sz minus 1. And here also we require a endpoint actually. Let's take another variable as endpoint, and endpoint is equal to I if I is greater than equal to sz, then endpoint will be sz minus 1. Now we can do everything on the basis of sz, not sz, endpoint, sorry, endpoint. I think this would work. Let's try. Okay, element found at index 7. So the basic idea behind jump search is, suppose we take here 30 elements, we have 31 index means 32 elements. If we take under root of this, we got a size of 5. We will look at a chunk of 5 elements, like from 0 to 4 index it's 171, we have need to find 690. So we make a jump of 5 elements, 450. Is it smaller? Yes. We again make a jump of 5 elements to 14 index. Is it smaller? Yes. We'll again make a jump of 5 elements, 631. Is it smaller? Yes. We'll again make a jump of 5 elements. Is it greater than the key? Yes. Now we will apply linear search in reverse order, 700, 690, and here we found the element. As here is duplicacy, we can found the element on any index. For in case of jump search, we gonna definitely find it on 22 index because it searched from the reverse order. So this is all about searching algorithms. Now I want to teach you something about C++ features. Let's do it on an online compiler. Hash include vector. Suppose we have vector of integer array and let the element be in sorted order. I have taken 5 elements. Okay. Now there is an inbuilt function in algorithms library. You can include the algorithm library, and it provides a function called binary search. For now, if you don't know about iterators, just keep calm. We will discuss them in later. Like I have provided two iterators to this function. Array.begin means the starting iterator, array.end means the last iterator. And it is gonna return me an iterator if it founds the element. Okay, it's binary search. I think it will return direct answer exists or not. And to this, what we are finding 45 element. Let's check if it exists or not. See, we got output as 1, which means it returns a boolean value and finds the element using binary search. Let's change the value to 24. Now let's find. Now it returns 0. So this is binary search, an inbuilt algorithm built inside an algorithm library. To this function, you provide two iterators, the beginning and the end iterator, and the element you want to found. Now let's discuss about lower bound. Lower bound means the element which is greater than or equal to. Okay, so to lower bound, we also found pass the same things, beginner iterator, end iterator, and the element. Now it returns an iterator, and to iterator holds the position of that element. Like the lower bound for 24 is 45, and we got the output as 45. If you want to find the index, we can do something like this: iterator minus array dot begin. This will give us the index where the upper bound exists at index 2. Okay, lower bound. Now there is another function named upper bound. It gives you the upper bound which is strictly greater than, not equal to. Okay, which is strictly greater than, let's take 45. So for 45 strictly greater element is 56, which is present at index 3. So these are the functions for binary search and lower bound and upper bound. Now there is also a function named find. It finds element in an array. Like we are finding 45, it will return 3. Like we are calculating index. Okay, 45 is present at index 2. Correct answer. And there is a conditional also, find if. To this we provide the same iterators and a function. Whatever the function returns will be considered as output. Like for now I want an odd number. This function returns true if the number is odd. and let's find which number it finds first. Like I have used a lambda function. Okay, written spelling is wrong. So first odd number is 23. If you want to find first even number, it will be 12, and there is conditional also. If not, find if not, then it will find the odd number, which is 23. So these are some STL functions which you will be using while doing competitive coding. So see you in the next lecture about sorting algorithms. Thank you. Also, you should give a read about all these algorithms. Let me give you a short description. Like in interpolation search, what happens? We are having a sorted array. Now it should also be uniformly distributed. Suppose we are having elements from 0, 5, 10, 15, 20 up to 50 with a difference of 5, and all are in sorted. So now you are asked to find a number 25. So what you do? You know that the difference is 5, and you directly divide 5 by 25, you get 5. You search at index 4 and you find the element. So the theory behind interpolation search is hit the index where the element is most probable to find. And exponential search is also a good algorithm. Let me tell you about exponential search. What happens in exponential search? We just double our boundary and then apply the binary search. Like it finds the range to which our element may be present. Like take the example of this array. We want to find 247. Okay, so we start our endpoint as 0, element is smaller, double it. Endpoint is like starting you can take 1, because 0 into 2 it will be 0, so you can take 1. Now doubling it, we reach to 93. It's again smaller. Again double it to 4. It's 134. Again double it to 8. It's 234. It's again smaller. Double it to 16. Now 475 is greater than this. So 16 will be our upper bound and 8 will be our lower bound. Now apply binary search from 8 to 16 to find this element. So this is the idea behind exponential search. Exponential search is very useful when your element exists in the starting of the array, or suppose the array has an infinite size. Then in that case exponential search is very beneficial than binary search. Thank you.